First, going to present a little bit about the recommended systems, what it is, a brief overview of different types of recommended systems. So that will be the part one. And the part two will be a hands-on tutorial to build a simple recommended system. And for that, you don't really need too much preparation. I will go through the prerequisites, so don't worry about it. But it's just going to be a simple Google Colab, which you can just use if you want to. Yeah. So then let's begin. This is a very famous quote that I came across, and I found it very apt for recommended systems because I guess every one of you have encountered recommended systems at some point in their life, like in some way or other. You may or may not have noticed that it is a recommended system, but I'm sure you have used it. So you are given plenty of choices, and then you need to narrow down your choices and then select a bunch of the things that are relevant for you. And that's exactly what the job of a recommended system is. And this is very important because once people are given so many choices, they are often overwhelmed and they do not know which one fits their interests the best. And hence, there's this quote. And as I mentioned, you have encountered recommended systems at all points, or like at some point in your life, I'm pretty sure, because they seem to be everywhere. For example, e-commerce, when it comes to product recommendations such as Amazon, Shopify, eBay, you name it, and you are using some sort of recommendation there, or a recommended system. You talk about social networks, so say newsfeed generation, friends recommendation, whatever, whatever posts that appear on your social media feed, everything is a recommended system. Online entertainment systems, so for example, Netflix, Spotify, YouTube, it is a recommended system. And then when it comes to trip planning and traveling, all the trip planning websites or the platforms that you use, from booking.com to Lonely Planet to TripAdvisor, you name it, and it is an example of a recommended system. When it comes to ride sharings as well, because it is a problem of certain resource being matched to, like a limited resource being matched to some people. So it's kind of a different way, but it is kind of an example of recommended systems because it is important that the person who is asking for a ride gets matched to the appropriate cab driver or whatever, So, yeah. And then when it also comes to, say, job search, using LinkedIn, Zing, whatever, that's also this candidate matching problem. So the two-sided platform, the matching, it is also an example of some recommended system. So now we have been talking a lot about the applications of recommended systems, but then it brings us to the question, what exactly are they, or what exactly is it? So recommended systems provide personalized suggestions. So they analyze all your past user history and all the information available about the users or anything. So any relevant data they use to generate your user profiles, and then past purchases, demographics, your preferences, your likes, dislikes, everything to build up your profile and then recommend stuff to you. So, and as I mentioned earlier, it is very useful to minimize information overload. How? I'll show you in a second. So this brings us to the next question, is that how do they actually work? So, but before I do that, I will introduce you to the recommended systems terminology because I think that's going to be relevant throughout the lecture or the workshop. So, yeah, so you have a bunch of users. I tried to use some familiar phrases. So you might be knowing, at least some of you might be knowing these characters. So you have a bunch of users who are interested in getting recommendations on a platform for certain things, so certain products. So you have the users and you have a bunch of items. So I just chose some random items that might be relevant for these users. And then, so you have like the simplified workflow looks somewhat like this. So you have the users, you have the items, and then you have, these are fed as input to a model where the magic happens. And finally, you get a ranked list of results, so according to the preferences of the users. And users can be here like a single person or can also be a group of users. But then our focus here is basically the model, where actually the magic happens. So another way of showing the recommendations, like why or how can it be used to minimize the information overload, is as follows. So if you have the item corpus, so a little bit more realistic example, you have the item corpus and you have a stage called candidate generation, which comes with a lot of popular algorithms such as like content-based filtering, collaborative filtering, context-aware recommendations, and so on. So some are like really popular and very the basics of recommender systems, while the other ones are a bit advanced approaches. So you have the first stage. So you like the item corpus takes in inputs of millions of items. There's a candidate generation thing happening. And then you take like hundreds, you get hundreds out of the millions, and then you use some sort of scoring mechanism and some ranking mechanisms. So you use the scoring mechanisms to rank the items into some dozens of like ranked list of results. And I'll explain what the re-ranking or why it comes, but before that you take into consideration also the user history and the context as the input to your candidate generation step and the scoring and ranking, so that is also relevant here. The re-ranking part comes is that when you have narrowed it down to dozens, and then the re-ranking often is required, say if there is some sort of bias present in the data or in the results, ranked list of results, then it is important that you use some sort of bias mitigation strategy to re-rank your results to mitigate that thing. So now I will quickly give you an overview of the very basic two recommender systems paradigm, so content-based filtering and collaborative filtering, before we dive into the actual part. So content-based filtering is basically, like, I think everyone has encountered that at some point in your life when you go on Amazon or any sort of product website, and then like you look for some products, and then you are often recommended stuff like, oh yeah, so you bought this, then you might be interested in this, or similar to this item, you might be interested in that item. You know, that is basically what is happening there, similarity-based, content-based filtering, or similarity-based recommendations. So say we have our favorite character here, who likes the Nimbus broom, and then there is a similar item, say the snitch, and that gets recommended to Harry. So that's basically what happens also in a real life content-based filtering. Next comes the collaborative filtering. It is basically like other users or who are similar to me have liked so and so. So maybe I will also like that. That is the intuition behind. So for example, we have Harry and Ron, who are similar users, and then both of them viewed this R jumper. So, and then we have this H jumper, which is viewed by Ron, but then it gets recommended to Harry because they are similar users. So the recommendation model thinks that maybe if Ron likes something, then Harry will also like it. So yeah. With this, I come to the part 2 of the thing, so the workshop. So if you're interested in like doing it together with me, feel free to copy this or scan this QR code. Yeah. I'm sorry, actually, I think I realized that you can't do it, like scan it on your laptop. Yeah.
But you can go to your GitHub, right?
Yes, you can, definitely. Okay, I'll give you a minute. Yeah, this is my first time hosting a workshop, so yeah, these are some of the lessons learned, I guess. Okay, even if you can't, I will be sharing all the resources on my GitHub, and in the end, there is already something like that you can actually have. So before we begin, the prerequisites are obviously Python 3.x, TensorFlow 2.x as well, because it's a workshop using TensorFlows, and last but not the least, Google Colab. So yeah, once more. So if you haven't scanned it, now is your time. So, okay.
Excuse me, are these slides also there?
Not yet, but I will upload them. So in the end, I will share a list of like further materials and resources, and then you will find everything there.
Oh, thank you.
Yeah. Okay, then would say let's begin. So the first part is obviously you have to actually wait a second. I'll try something else. Yeah. Okay. Let's workshop. Yes. So the first step would be to install stuff. So pip install TensorFlow recommenders. Yeah. Can I get a show of hands of how many of you are actually doing it, or okay? Oh, okay. Cool. So just let me know if I'm too fast or too slow, and we will adjust the pace accordingly. So yeah, I think this is quite basic. So to install the recommender systems or TensorFlow recommenders, and then do some basic imports and utilities. So yeah. And the next step would be I define some user function here to just pretty print stuff. So yeah, utility function to pretty print stuff. It won't run actually because I didn't run the above steps, but let's see. I want to show the yeah, that's what I thought. Maybe I run it with you. Okay, so just a quick show of hands if you're done with step 0. Okay, then let's move on to step 1. So the step 1 would be to pre-process the data. We are just using some pre-loaded dataset from TensorFlow and the very famous dataset called the movie lens. And so it has, I'll show you here. I'm not sure if you can read, but if you run the cells, you will realize yourself that it has a bunch of movies that with movie metadata. So that's our items set, and you have the ratings, so some user information and the users who rated the movies and the movie ID and the ratings for that particular movie. So yeah.
Is this a table format?
This is a TensorFlow dataset, so it's in the TensorFlow format, yes. But Movie Lens is available as table format, so if you just download it, yeah, it's. So I just wanted it to be easier for Colab and stuff, so yeah. But it is possible to do it in CSV format. Yeah, so dataset downloaded, as we can see here, and then if I do the pretty print thing here, then as you can see that we have all the rating information. So rating has movie ID and movie title, and the user ID. So the particular user has rated this, and there should be, yeah. Also the movies have movie genre and movie ID and movie title. So the next step would be to clean up the data because we don't need all the stuff. So what we do here is we try to clean up the data. Okay, one more feedback from you. So should I show it like this, half screen, or should I just show the Colab?
Colab, because it's taken from Colab.
Exactly, yeah. So okay, then I just show you the Colab. Yeah. So yeah, so we do some data cleaning because we will only keep the user ID and the movie title keys. So yeah, I mean, this is also, I think, very preliminary stuff. And the next step is the obvious thing that you need to do in a machine learning model training thing is like to do a train test split. We do the 80-20 split here.
Excuse me, is it a supervised approach?
It is a little bit, like it's a mixture of both. So I am using like, I think it's more of unsupervised. Yeah. Yeah. I mean, it's a query tower, and then I'm just like combining models together, so it's not really, yeah, everything. So yeah, I do the train and test split here. Okay, and then we just do like unique movie titles stuff. So these are basically the pre-processing steps. I think they are pretty obvious and evident. Yeah.
Evident if you know how data looks like and what kind of issues are there, right?
You
the
can
code
see
itself is trivial, but
Yeah.
you need to know why.
Yes, so you can see how the data looks like here. So yeah. And I mean, this is also a very basic model. Obviously, if you run it in production, this will not work. Just a disclaimer. This is just to give you a feeling of how you can possibly use TensorFlow to build recommender systems. Yeah. I mean, otherwise it gets a bit difficult to cover it all in 55 minutes. So.
And is user IDs aggregated?
The users' IDs are aggregated, yeah. Yes, so how many people did I lose already? Okay, good. Let's see how far we stay that way, or how long we stay that way. So the next part is the model implementation. So you have the user ID and you have the model movie title. You can keep adding more features there, but here, just for simplicity, we have all the user info and we have the item info, and then we create some user embeddings and item embeddings, and we just combine them to build our recommender model. And all these things are kind of handled by TensorFlow recommenders. So the base model of TensorFlow recommenders, which is using Keras under the hood. So yeah. We call this thing the user embeddings, the query tower, because it is the query. So in the end, the user is gonna say like, okay, user, like give me recommendations for user 35. So then this is the query, and the other one are the item embeddings. So the candidate tower, so those are the candidates that will be generated. So for that, first we need a dimension. So we define the dimension as 32. And then we define the user model here. So it's a very like simple Keras model, where we use the user IDs and integers and then convert them to user embeddings. Yeah, and we use the list of the unique user IDs that we earlier computed. Yeah. So this is kind of like a matrix factorization approach. So later we will, like under the hood, it computes matrix factorization. So it has the users matrix, it has the item matrix, combines them, matrix factorization, gets the model. So, yeah.
Is it just like a RNN model?
It's a matrix factorization, it's a collaborative.
Not sequential.
Yeah. Sorry?
Sequential model.
Yeah, so it's a Keras thing, so yeah. I'm not sure about that. So it's like yeah, probably. I'm sorry.
No, really, this is just an API, so there's
Yeah.
a functional API. So you either specify layers one by one, or you can combine them like in parallel, pretty much. So that's why it's a question. Because you stack layer content.
Exactly. So if you are building any sort of neural networks, then you keep stacking these things, and yeah, you can build your own thing. So yeah, the Keras API. And yeah, so next we have the candidate tower, where we have the movie models. Like similarly, we built the candidate tower. And the next step would be then to define the metrics. So here we use like the factorize top k. So we have like a factorization, matrix factorization, and then we use the top k things. And the next step would be then to define a loss function. So, how many of you are with me? Or how many did I lose? Maybe easier to ask how many did I lose? Okay, people are too modest. Yeah, so now the next step would be to combine them all together in a full model. I'm not going to go into the details, but yeah. So we have the thing, and we are using the TFRS model base class. And now we have the instantiation. So the basic like model training, fitting, evaluation. So yeah, and we will do some cache train and test. Now the model fitting, this might take a while. So while this runs, any questions? Yes.
I have a question. During that filtering stage where we removed unnecessary data, why did we remove the actual user rate? We left only movie title and user ID, so it's not important what user actually rated that movie.
Yeah, so first of all, I mean, for simplicity reasons, we removed like most of the things. And did we remove user ratings? Okay.
Because the user rating is
Yeah, because we are also going to predict the ratings at some point. So in matrix factorization, actually I had to remove the matrix factorization slides because I thought that I would run out of time. Yeah, there, if you could see that for the ones that we are going to predict, we removed the matrix factor, the user ratings, because we would like to predict it from the user type 4.
So it will be used in training set?
Yes. Just a second. Sorry, I also am doing this for the first time. Yes. Okay, let's see.
Thank you. One more question
Sure.
about model. I'm not familiar with that string lookup layer. What actually features, based on what database will be predicted for user and for movie?
Sorry, can you go to the line number? Wait.
Line number.
Or some.
It is step 2.1.
Okay.
And there is a sequential model with first layer string lookup. And what are actually features of that?
Yeah, so it is some like it's a very specific to the Keras library. So it's like that's how it is, unfortunately. So then you like use the vocabularies as the unique user IDs, and then it somehow works. Sorry.
Well, after that model, similar users will have similar ratings, or not?
Yes, that's yeah.
Clear how it goes.
Okay, so yeah, and let's see how does this work. This is also going to take a bit. So yeah, we have some information here. Let's just ignore this thing because there's severe overfitting going on. So and like it also sometimes recommends movies that have already been watched, and so yeah, it's not ideal, but this is something like this. Yeah. In reality, actually, we try to exclude the movies that the user has already watched to give novel recommendations. But then, yeah, here we did not really do that. So now it's the last step to make the predictions. So, yeah, we have the thing here, and we would just like to see if it works. So we used for user 42, and then we see that like these are the movies that are recommended, like the movie titles that are recommended for this particular user. So, yeah, this is the next step. So I just quickly go through the slides. If you are through, then we did it. And how many did I lose in the process? So I lost.
I'd like to.
Sure.
We trained the map basically from our users into some embedded space, or embedded vector space. So each user is given a vector. So if I take a user, number 42 here, I take the closest vector in this space for this user. And then I recommend what? I recommend the things that this closest user liked.
Yes.
Or do I use this matrix factorization to calculate his sum?
So you use this to calculate, in this case, you can also use a similarity-based approach, like you can use some similarity matrix to find that what the user, what is the most similar things to the user. But in this particular case, I think you used matrix factorization to calculate what the user will like, so the embeddings that will...
So we just took a multiplication of
right.
this vector to
Yes.
Excuse me, what similarity metric are you using?
So I'm not using anything here at the moment, but you can use like cosine similarity or anything else. Like, yeah, it depends on which spectrum you are. Like any sort of distance matrix you can use. So, yeah. Okay, so the next steps, you can serve your model using TensorFlow X. You can learn multitask models or item metadata. You can make it way more complicated and way more convoluted compared to what we did, because it was a very, very simple thing. And with this, I come to the actual end of the thing. So it's a quick recap, but maybe I could also use a little bit of I had some backup slides, so maybe I could discuss them. As I said, this was my first time doing the presentation, so I couldn't really gauge how it was. But so I wanted to discuss a little bit about the pros and cons of content-based filtering. So when it comes to the pros, you have this whole point of there's no new item problem, and it is very well scalable, and often no explicit user profile is needed. While on the con side, you have that the item model is limited explicitly to explicitly analyze features. So it cannot take information on the other users and then predict stuff. And you obviously require special expertise to build this model. And this can also be prone to overfitting because you're just using the item metadata, and then there could be there's not too much novelty in the data, lack of diversity. So when it comes to the pros of collaborative filtering, actually has been seen that it works pretty well in practice. And there's no item metadata required because you just check the things of different different users, and then you like see like how similar the users are, and you can do that, and then you have like cross-domain recommendations. Whereas on the cons, there's often the cold start problem, because if you're a new user on a new platform, then you might not have enough activity on the platform, and then you might not have enough ratings for items, and or then there could be problems.
And how could you solve this problem?
There's no particular like thing that okay, this solves the cold start problem, but what we usually do in research is that we use a combination of collaborative and content-based filtering, and then that helps to minimize the cold start problem. So, and then another big challenge of the recommended systems community is that the data sparsity, because there could be a variety of items, but then not enough users have rated those items, and then there is like a sparse matrix. And often it is also prone to manipulation. So, for example, users can be influenced to rate a certain item in a certain way, which is influential to the item's benefits or something like that. Okay, so with this, I come to the end of the presentation, and I will be happy to hear your questions.
Thanks for the presentation. Love the memes.
Thank you.
Thanks.
So what did you do to, because your result was like the model is overfitting, right? So how would you fix that?
I mean, I would definitely use a lot more data first.
So because you divided it into training and testing.
Yeah, and it's not like, it's like what, 80,000 data points, I think, in the training set? Not enough. So I would use a larger data set, and then I would try to like see if it works, and then some fine tuning of the model, some hyperparameter tuning or something, yeah. I mean, that is kind of the experimental part of the thing.
So if you are doing hybrid recommendation engine, how would be the weight between collaborative and content-based?
How, sorry, I didn't get it.
I mean, the question is how you assign weights to different
Experiments, and also depends on your data set, what kind of data set you are using and how much data you have and what kind of experiments, like you have to like, I think there is no out of the box thing that okay, you have to like 2 times content based versus 3 times collaborative will work, but you have to see and like first collaborative, then content based, or like first content based collaborative, so on. Yes.
Do you have some knowledge about how many data points I need for a new customer? Because talking about this cold start problem, I think often it's very obvious if you came, for instance, to a website, first time, you see that the recommendations are more or less made on the average, and then after like just 1 minute searching for something, so you directly see that the algorithm starts to get to know you. Even for Amazon, where we have like millions of articles, do you have some knowledge about like after how many touch points, how many views you have like good results? Because I have no really experience with collaborative filtering, but just as a user, I think that it's very fast.
Yeah, it is. I mean, for these guys like Amazon or these like big product companies, I mean, they have access to huge amounts of data. So it's for them it's pretty fast. But if it's a relatively smaller thing, then probably they also have sparse data, and then it's harder. So again, it depends on if you're working with LinkedIn or Amazon or whatever, in a big company or big website, it's going to be a lot faster. But there's no like hard limit that you need to have 1,858 data points or something. Okay.
I have a question.
Yes.
So after this step, what would you do to make it more complex?
I mean, one, I could use different data sets or like information from other data sets which could be relevant for this thing. I could use like other demographic information of the users if available. So I will try to make it like feature rich that way. And that could be one step to, and then I mean, I could use the item metadata also in the model, and yeah, like that.
But as we saw, it takes user ID and movie's title as input. So in the side of user ID, you can attach the demographic
Yes.
data and create like a custom variable. And same goes for the movie, you can add genre or
Yeah.
something else and then create custom here. But it would recommend against that custom filter, not against the user then.
It will recommend against the customer thing, so it will recommend for the customer, so it depends on what it has been trained on. If it has, so the user embeddings, if you remember the model thing, here. So for example, it's just user ID here, but you can add all the user demographics or the user information, and you can add all the movie metadata here, and then it will still do the same thing.
So it's kind of clusterization.
Yes.
So I was thinking whether you need to do clusterization and then apply this, create different recommendations for different clusters, or you
I
can
mean,
do it in this one.
Usually you cluster different, so if you know, like say the Twitter recommended algorithm, that also clusters similar users together or similar items together, and then it recommends based on those clusters and not individual users. So that could also be an approach, but here this is like way too simple for that.
I have a
Yes.
question about maybe testing the validity, or like this, if it is still giving out valid results. Because if you have like some inputs over time, then if you use, for example, the similarity between users, then you can have like millions of customers, I guess. And how do you know that the model is still giving out the results that it quote unquote should, right? Because with computer vision, for example, you can see if the result is valid or not. If you have like, I don't know, quality inspection or something like that, so that's super easy.
Yes.
But I guess here in this area it can be quite problematic if it's complex.
This is actually an open research question, and I can also say that, for example, what you can do in general is that you can ask your users that whether they are satisfied with the results.
Yeah.
So yeah, and then you can measure the user satisfaction from the results, and then you can say that
So for example, Netflix, they would at the start calibrate the model,
Exactly.
right? And then they would rate, okay, how do you like these recommendations?
Exactly. So you get like feedback from the users, and then you fine tune your model accordingly.
I think that you get explicit feedback as well. You
Yes.
don't necessarily have to ask, because you can take a look at like the ratio, how many people click on those
Yeah.
segments,
Yeah.
right? And if you compare it over time and you see that like this amount decreases, you have a model drift issue maybe, and so you have to retrain or whatever.
Yeah. So you can use like implicit, explicit, all sorts of feedback, and you can also do user surveys later for research, then whether they are happy with the things, like explicit user surveys, and yeah.
I never thought about this. It is quite complicated in comparison to at least the computer vision stuff,
Yeah.
This is a topic, I guess.
Yeah, actually my research focuses more on the ATI side, so I'm still learning a lot of the deep learning part or the neural network and model implementation parts actually. So yeah, the ATI side is more comfortable for me. Yeah. Okay, any other questions? If not, then thank you very much to everyone for attending.